morning to all. I will start the session. Before going to the today's session, first I will discuss what happened in the last session. In our last session, the main topic is related to static keyword. Based on the static keyword, the static keyword decides the memory location. Everyone concentrate. The static keyword plays very crucial role. The static keyword decides the memory location. Based on the static keyword, the variables. What is the first component? The first programming component, the basic part is variable. Variables are categorized into two types. One is static variable, another one is non-static variable. Now, coming to static variable, a variable that is defined outside of the method. Remember, the static variables are defined outside of the method. Everything is within the class. Obviously, everything is within the class, but outside of the method, prefixed with static keyword. Those are called static variables. So the static variables will get the memory inside the class. Will get the memory inside the coming to non-static. These non-static variables are categorized into two types. One is instance variable, second one is local variable. If any variable that is defined outside of the method, that is called instance variable. Instance variable will get the memory in the object. Okay, we'll get the memory in the object. Now, finally, the variable. The local variable that are defined inside the method. That is, whenever we call the method is executed and the variables inside the method are executed. Once completed, destroy the variables. So these are the variables. Anyway, we will discuss one more topic here. After that, I will go to the internal memory. So by the end of today's session, you will get the complete idea what happens inside the Java program. Okay. Now, coming to the today's session, the topic is methods. Up to now, we discussed variables, now methods. So, what is a variable? Variable is simply a data holder used to store some value. Similarly, what is a method? Methods are simply an actions. Methods are simply the actions which are executed to generate some result. So, methods are simply performing some actions to generate results. Again, based on static keyword, always remember, based on static. Why? Again, I will repeat. The static keyword decides the memory location. The memory location plays very crucial role. Based on the static keyword, the methods are divided into two types. One is static method. Second one is non-static method. One is static method and second one is non-static method. This non-static method is also called as instance method. Only two types. There is no local method. Variable means inside the method, but this is the concept of method. So there is no concept of local. Static method and non-static method. Okay. We will discuss one by one. First one, static methods. Static methods. So Obviously, you are creating a method in your program. The methods which are declared with static keyword. Static method means the methods which are declared with static keyword are called static method. So this is also called as class methods. The static methods also called as class methods. Now coming to the point where the memory is allocated. Remember, the static methods will get the memory. The static method will get the memory within the class. Within the class, while everyone remember this point, while class loading. That is whenever you are loading your class into the memory. Whenever you are loading your class the first time. So the static methods will get the memory. The static method will get the memory. And whether it is a static variable or static methods, generally these are accessed. Static methods are accessed by using class name. What is this one? So generally observe the method is available inside the class. Now if you want that method, how can we access? By using that class name. If you want, you can access by using class name. Okay. What is the syntax of a method? I think everyone know the syntax of a method. It is similar to C language. Similar to C language. So syntax is return type followed by name of the method within brackets parameters. Open. Here you are writing some set of statements, close. So this is the general method syntax. This is the general method syntax. Return type, name of the method, parameter. So I will explain one by one. What is parameter? Simple thing. Parameters are, so within the method what we are doing, inside the method we are performing some operation. So to perform some operation we need some input. So simply the parameters are simply input to the method. The parameters are input to the method. Based on these parameters, the corresponding operation is performed. Generally, a method consists of with parameter, without parameter. That is depending upon the program, depending upon the method, we can pass the parameter, or if you are not required, simply ignore. So whatever it is, if you have parameters, the parameters are simply input. The parameters are simply input. Simple sense to transfer the data from one method to another method. Method with parameters, a method without parameters. Now, what is return type? Return type specifies simply the output. Return type specifies the output data type. Okay. Suppose after performing some operation, you are returning some value. You are returning some value after completion of your operation. So here also a method which consists of return type, that is after completion a method will return the value, or a method it doesn't return any value. Suppose if a method return an integer value, so data type integer, float value, data type float. Suppose if a method doesn't want to return anything, void is the return type. Okay. So exactly whatever the syntax we are used for C, here also used the same syntax. Okay. This is the structure of the method. Now coming to static method, what I said, the static method is a method which is prefixed with static keyword. So this is the syntax. So static keyword is used before the method. You are using static keyword, then this method becomes the static method. Method becomes the static method. So the static methods will get the memory in the class while class loading. So the static method can access only static variables. The static method can access only the static variables. Why? Observe my point carefully. Static, whether it is a variable or it is a method, the memory is available inside the class. So the static variable will get the memory inside the class. The static method also will get the memory inside the class. Both are in the same class. So it is possible directly the static methods can access the static variables directly. There is no problem. Why? Both are in the same memory location. Both are in the same memory location. But it does not access instance variable. It does not access instance variable. Why? The static method is available inside the class, but the instance variable, the memory is available inside the object. Both are two different memory locations. So directly it is not possible. Clear the point? Understand in terms of memory. And the next one is second method. Instance method. Instance method simply the methods that are declared without static keyword. The methods that are declared without static keyword are called instance method, are also called as non-static method, are also called as object method, are also called as object method. Now, where this get the memory? The instance method will get the memory within the object. The instance method will get the memory within the object while object creation process. That is, you are creating an object. During the creation of an object, all the instance members will get the memory. What is the syntax? Same method syntax, return type, name of the method, parameters, here the body, and then close. This is the syntax. So without any static keyword. Think you clear the point? You clear the point? So this is instance method. Now instance method will access both static variable and instance variable. Both static variable, instance variable. Why? Sir, you already said that previously. The static variable will get the memory inside the class. Static methods also will get the memory inside the class. Both are in the same memory location. That is the reason static method access the static variable directly. But coming to this topic, the instance variable will get the memory inside the object. The instance method also will get the memory inside the object. So, a method, instance method can access the instance variable directly. But the static variable will get the memory inside the class. How it is possible? How means simply an object is created for a class. What is an object? Object is an instance of a class. A class generates the object. A class generates the object. That is the reason. By using the object method, we can access the class variables also. We can access the class variables also. Okay. Now, we will discuss one program. The program consists of static variable, instance variable, static method, instance method, and observe carefully class demo method. This is my class name. Now, before writing the main, I already said everything is written outside of the main. Always your program execution starts from main. Anyway, you will understand. By the end of today's session, you will get the complete idea. Static int sum a is equal to 5. Static int a is equal to 5. What is this one? This is a static variable. Now int sum b is equal to 10. Int b is equal to 10. What is this? This is an instance variable. This is an instance variable. Now static void some display of just I am display means just I am printing the values. Here I am not doing any operation. For printing system dot out dot print ln. So print the value a is equal to, I know, I think everyone know, a is equal to within the quotation exactly that is printed plus is used to add your output a end with semicolon, end with semicolon. S is the predefined class. So capital S system dot out dot println. Okay. Now anyway, first I will type system dot out dot println b is equal to plus b. Close. This is my static function. This is my static function. In the similar fashion, I will create one more function. For example, the method name is assume the method name is show is the method. Here also I am printing a value and b value. Now observe carefully. Now observe carefully. Okay, I mute them. I request all, please mute. Okay, coming to this one. So wide show off. This is an instance method, and here I used the keyword static. This is a static method. This is a static method. So what are the points we discussed? The static method cannot access the instance variable. But here I try to use. So anyway, I will execute. It will give an error. I will show you the error also. Now after that, public static public static void main string args of. From this, right now you know one point. First point, main is the method. Based on the syntax, main is the method. Void is the return type. That means the main method does not return any value. The main method does not return any value. Now, static is the keyword. The static keyword specifies the main method is loaded inside the class, and main is the starting point of execution. Everyone remember, your program starts with main only. Your program starts with main only. Okay. Now coming to this one. Your program starts with main. The main is executed automatically. Why? The main is static. Whenever you are writing the static means it is all automatically loaded for execution. Now, how the remaining methods are executed? Your control right now at this position. You understand my point? Your control is within the main. Then how the display and show methods are executed? Remember, in a program, Whatever you written inside the main, that is only executed directly. Inside the main is executed directly. If you written anything outside the method, you need to access. You need to access. How? See this example. So if I want to access display method, display is display is a static method. I said, how can we access a static method? By using class name. Again, I will repeat, we can access the static member, whether it is a static variable or a static method. Generally, the static are accessed by using class name. What is my class name? Demo method dot display. Why? The static method is available inside the class. Again, I'm repeating, within the program, even though you are writing this is the top of the program, this is not executed. Always the program starts its execution from the main only. Program starts its execution from the main only. This is the first statement. Within this one, this is the first statement. Whenever this statement is executed means we are calling the display method. Whenever you are calling the display method, then this method is executed. Then this method is executed. Now, how to call this method? I think you got it. Whenever you are calling, then only the corresponding method is executed. Without calling, except main, without calling, no method is executed. Now, show is an instance method. Instance method are accessed by using an object. So, obviously, what is your step? Create an object demo method, some object ob is equal to new demo method of. In this way we are creating an object. We are creating an object. Now ob dot show. Now the show method is executed. Simply close the main and then close the class. Okay, this is the program which consists of one static variable, one instance variable, one static method and one instance method. Okay, save the program. So here I will save directly demo method dot Java. Demo method dot Java. Save. Close. Again I reopen. CMD. Don't forget. Command prompt. CMD. Click on this one. Directly D drive. In the D drive directly I saved the program CD Java C space demo method dot Java. Java C space demo method dot Java. See this one, Rao, you are getting one error. See this one. Okay, this is not. Ignore this one. Execute one more time. The error is inside the static method. You are trying to use instance variable. See this one. Non-static variable B cannot be referenced from a static context. You got my point? B is the non-static variable. It is not possible to refer B inside the static. But inside the instance, it is possible to access static. Why? Why in the sense static means the memory is inside the class. It is not possible to to access an object, but object can access. Why? An object is generated by the class. An object is generated by the class. Now execute the program. I place that one in comment. Comment means that statement is not executed. The statement is not executed. Okay. Java space demo method. Okay, we are getting the exact answer. Fine. So right now we discussed two concepts. The based on static keyword, static variable, and based on the static keyword, we discussed the concept of variables and methods and their categorization. Now, before going to the next concept, I will explain. Based on static, we have static block also. But before going to the topic, now I will discuss the JVM architecture. JVM architecture with in detail. That is JVM architecture with internals. So then you will get the complete memory idea. What is JVM? JVM is the full form is Java Virtual Mission. What is the purpose of JVM? JVM is used to execute. JVM is used to execute the bytecode. JVM is used to execute the bytecode. What is the bytecode? What is the bytecode? Whenever you are writing a Java program, after compilation, it generates the dot class file. It generates the dot class file. So that dot class file is called the bytecode. This bytecode is loaded into the JVM for execution. The bytecode is loaded into the JVM for execution. Now, internally, JVM mainly consists of three parts. That is, the entire JVM is divided into three basic components. The first one is class loader subsystem. Class loader subsystem. Second one is runtime data area, and the third one is execution engine. So internally the JVM is divided into three partitions: class loader subsystem, runtime data area, and execution engine. Anyway, we need to understand this runtime area in detail. Runtime data area in detail. Now, I will write down in the diagrammatical format. You will get some idea. First, this is your source program. This is your source program. For example, here I written the program as demo method. So assume the same program, demo method dot java. Yes or no? Demo method dot java. Generally, this is called source code. This is called source code. What happened for this source code? If you are doing compilation for the source code, you are doing compilation. How I done the compilation? This is the syntax I used: Java C space demo method dot java. After compilation, what it generates? After compilation, it generates demo method dot class. Yes or no? First stage is compilation. After compilation, it generates the dot class file. The dot class file is called bytecode. Now what you are doing? The bytecode is moved into execution. For execution, I type the command java space demo method. Whenever you are writing this statement, now the dot class file is moved to execution. So For execution, the method is loaded into JVM. Now coming to the JVM part. I said inside the JVM, my first partition is class loader subsystem. My first partition is class loader subsystem. So this class loader subsystem internally consists of some loaders. Internally consists of some loaders. Now, what is the use of this class loader subsystem? Simply, the purpose is to load the dot class file, that is to load the bytecode, into the runtime data area by using these loaders. Now, what is the purpose? Runtime data area. Suppose first I will explain that, written the diagram, then you will get the complete idea. So, this is my second partition. What is my second partition? Runtime data area. Based on this one, you are getting 1 point. Based on this one, you understand 1 point. Runtime is during execution. Runtime is during execution. The memory, that is the program, is stored at this position. Okay. Now, this runtime area, see this one. This is divided into 5 partitions. The first one is method area. The runtime data area is divided into 5 partitions. Method area. Second one is heap area. And third one is Java stack engine. Remember these three names, at least these three names. So, method area, heap area, Java stack engine, and the next one is PC, program counter, PC register area, and the last one is you are getting this PC register area whenever you are in the topic of threads. And the last one is native method area. Okay, right now you are getting only the first three. Native method area. Okay, so these are the 5 partitions of runtime area. Okay, now I will explain one by one. What is the class loader subsystem? The class loader subsystem is simply to load the dot class file, into the runtime data area. To load the dot class file into runtime data area by using their internal loader. Loader is used for loading. Now, coming to the second partition, runtime data area. Runtime data area is mainly divided into 5 partitions. Method area, heap area, Java stack engine, PC register, and then native method. Now understand one by one. What is method area? Method area, another name is class area. Don't confuse. Method area name is the class area. Simply, what is the method area? The method area is the memory location where the class is loaded. So up to now I am using the word class is loaded, object is loaded. So method area means, so this is the place whenever your program is executed, during execution, the classes are loaded at one place, that is static members are loaded one place, instance members are loaded at one place. Exactly. So method area means simply the area or the memory location where your class is loaded. Now what is the meaning? while class loading. Whenever the class is loaded, while class loading, all the static components will get the memory inside the method area, whether it is a static variable or a static method. If it is a static variable or static method, will get the memory inside the method area while class loading, whenever you are loading the class. And everyone remember, main is the static method, yes or no? Main is the static method. So main is the static method. Clear? Now, second one. What is my second one? The second one is heap area. Heap area means the memory location where the objects are created. Simply, the memory location where the objects are created. This is called heap area. Now, within the heap area, all instance members. So while object creation, all the instance members will get the memory within the object. Up to now, only two types of memories. What are the two types of memories? One is the memory with static, without static. All the static members will get the memory inside the method area while class loading. While class loading, that is the very important. So only one time is loaded. So you are using the class multiple number of times. Even though you are using the class multiple number of times, one time is loaded. Now all the objects will get the memory inside the heap. That means method area is related to classes, heap area is related to object. Heap area is related to object. Now, what is the third one? Java stack engine. Remember what happened? The Java stack engine means simply the memory location where your methods are executed. So remember, inside the method area, heap area, just to loading, they are not executed, just to loading. If you are, suppose here in the previous example, you are calling the method ob.show. Whenever you are call the method, then the method is executed. So for executing the method, all the methods are moved to Java stack engine. You clear the point? All the static method will get the memory here. All the instance members will get the memory here. Now Java stack engine means simply the memory location where the methods are executed. The methods are executed. Now coming to the point main. Now coming to the point main. Main is the static method. Main is the static method. It is copied automatically. The main method automatically means you no need to do anything. Automatically copied into the Java stack area and start the execution. Java stack area and start the execution. So from this main method, we are calling the remaining method. From this main method, you are calling the remaining method. You clear the point? Clear the point? Now, for this execution, I have some third partition. What is the third partition? The third partition is execution engine. Execution engine, it mainly consists of two components. One is interpreter. So the second step after compilation, interpreter. Next one is JIT compiler. I will discuss these things later. JIT compiler means just in time compiler. So this is related to this one. That is during execution. I said Java stack engine where your programs are executed, where your method is executed. During execution, it takes the support of compiler and interpreter. Compiler and interpreter. This is the required thing. Anyway, we will discuss the native methods at the end, almost at the end. Here, some additional topic is there. Some module JNI which is related to Java JIT compilers, and here we are consists of Java native method library. So this is completely related to this one. Right now you are not understanding, no problem. Okay. So finally, what is the point? JVM architecture. I will repeat in 2 minutes. Understand. What is the purpose of JVM? JVM is a Java virtual machine used to execute the bytecode. So for executing the bytecode, internally my JVM is divided into three partitions. The first one is class loader subsystem. Second one is runtime data area, and the third one is execution engine. Coming to the first point, what is loaded? Only the bytecode. So that is the reason after compilation it generates the bytecode. The bytecode is moved to class loader subsystem. Now the class loader subsystem internally consists of some loaders. By using that loaders, they are loaded into runtime data area. Anyway, the runtime data area is divided into five partitions. First one, method area, heap area, Java stack engine. So method area, while loading, while for execution means the compulsory class is loaded. While class loading, all the static components will get the memory inside the method area. During object creation process, all the instance members will get the memory inside the heap area. So here just loading, but for execution, those are loaded into the Java stack engine. The execution, they are moved into the Java stack engine. Okay, the Java stack engine internally needs the support of interpreter engine. And very important point is main method. Main is the static method which is loaded automatically. The main method automatically loaded into the Java stack area. Sorry, Java stack engine, also called as Java stack area. So for execution, and within the main method, you are calling the remaining methods. Now, so right now you understand one point. Up to now, all those are basics. The main important three terms we discussed are variables, methods, and then this thing. That is Java execution. Now, I will explain what happened inside the JVM internally. Inside the JVM internally. Consider this example. According to this example, I will write down. So, okay, clear? Now, this is this is method area. So anyway, by using class loader, it is loading, everything has happened. Directly I am explaining how the your program is loaded. Observe, this is method area. Assume this partition is heap area and this one is Java stack area, also called as Java stack engine. Java stack engine. Okay. Now first step. What is the name of your method? Demo method. What is the name of your method? Demo method. So inside the method means where class. Where the classes are loaded, the classes are loaded inside the method area. Whenever you are using the class, not all the components are loaded. I already said only main is loaded. Assume this is the main method. Assume this is the main method. What happened? This is the first two. Again, I am repeating. In the method area, I have one class. My class name is demo method. So the demo method class is loaded. Remember, remaining components are not loaded. When the remaining components are loaded, whenever you start execution, then only the remaining components are loaded. So what happened? The main is loaded. First, the main is loaded. Clear? Whenever the main method is loaded, whenever the main method is loaded, what happened? I already said main automatically copied to the Java stack area for execution. Main automatically moved to the Java stack area for execution. Now, you need to remember one point. Inside the Java stack area, one partition is created that is called method frame. Inside the Java stack area, for each and every method, one method frame is created. Simply, this is the partition in the Java stack area. Simply, within the frame, my method is copied. A frame is created. Within the frame, my method is copied and starts its execution. Once that method is completed, once the method is completed, the frame is destroyed automatically. Clear the point? That means instead of blindly loading all the methods inside the stack area, for each and every method, one frame is created. Once the method is completes its execution, the frame is destroyed automatically. Suppose, understand, for your understanding, I written like this. This is called method frame. What is this one? This is called method frame. For each and every method, method frame is created. Okay. Now, what is the first step? The main method is automatically copied. So the main method is automatically copied into the Java stack area. Okay, this is my main method. This is my main method. First step is completed. Coming to this one, this is my first step. Now, coming to the points carefully, what is my next step? Main is loaded. Within the main, my first step is demo method dot display. Yes or no? Write down this one. Demo method dot display. This is the first statement executed. Yes or no? Yes. Whenever you are calling the display method from the demo method, understand carefully. That means here you are using the demo method. Yes or no? So main is not considered. You are using the demo method. Whenever you are using the class name, automatically the entire information in the class is loaded. Again, I repeat, I am using the word while class loading. While class loading, this is the first time. This is the first time you are using the class. Up to now, you don't know anything. Up to now, you know only main. So the main is copied into Java stack area. Within the main, this is my first step. Demo method dot display. That means you are using the class demo method. Once you are trying to use the class demo method, what happened? The class is loaded, the remaining components. So observe, first static variable. First static variable. Is the static variable will get the memory? Yes. The static variable will get the memory. A is equal to 5. The display method is not called. Up to now, we are not execute the display method. The static method, this demo method, the static variable is loaded. Static variable a is equal to 5 is the first statement. Now what is the second one? B is equal to 10. So B is equal to 10 into means the memory is not allocated. The box represent the memory is allocated. Into means the memory is not executed. Sorry, the memory is not allocated. Now next one, void display. This is the static method. So display, the memory is allocated. Display, the memory is allocated. Now show is the static, non-static method. The memory is not allocated. These things happen. Clear my point? Whenever you are using the class for the first time, if you are using the class for the first time, all the members of the class loaded into the method area. Among all the members, the static members only will get the memory. A is the static variable, will get the memory. Display is the static variable, will get the memory inside the method area, also called as class area. After that, what happened? Okay, the class is loaded successfully. Now you are calling the method display. Is the display method is available? Yes. Now the display method is a method frame is created. For each and every method, a method frame is created. Here it moves to the a display method is created. Go to the display method. What happened here? Just to printing the value, so it prints the value a is equal to 5. How you get the value? Display method is available here, a is also available here, both are available in the same memory location. Now I got the a value 5. Observe, now here trying to print the b value. Here there is no b value. So up to now b value, no memory is created. Then if you are trying to use, it gives an error. I think you clear the point. That is the reason a static method can access static variable only. Now close the bracket. That means my display method is completed. Immediately destroy the frame. Completed means immediately destroy the frame. Everyone clear? So first time, while you are using the class first time, the entire class is loaded. In that loading, all the static members will get the memory. After that, I call the display method. I call the display method. Whenever you are calling the method is loaded. So here, first time, sorry. Okay, see this one. This is my first step. It is done automatically. Actually, you no need to do anything. This is done. The main is loaded automatically. You no need to do anything. After that, what happened? You are trying to use demo method. The display method is loaded. Display method is loaded. This is my second step. Originally speaking, this is the first step. Why? Main is loaded automatically. The display is loaded into the Java stack area. Coming to the next point. What is that one? You are creating an object. Now coming to the syntax. You are creating an object. Demo method. OB is equal to new demo method of. Now follow carefully. What happened? Always first the is equal to right side is executed. That means first new method is executed. New. Whenever new is created, new executed means some memory is created. Some memory is created inside the heap area. Memory is created inside the heap area. That is for object. New is used for object. So inside the heap area with some address. With some address. Assume the address is some 0x11. Any address. General for assumption I am using this address. So first new, once the new is executed means some just memory is created. New is used for memory creation. New is used for memory creation. After that, whenever the memory is created, whenever the memory is created, so this is executed. Demo method of. Okay, by this end, what happened? All the instance members will get the memory inside this new location. That means this is my next point. This is statement number 3. B is equal to 10. Now it will get some memory. B is equal to 10. Clear? So whenever the memory is created, after that you are calling the method. So the instance members will get the memory inside the heap area. Okay. Now what is the next one? Show method. Show method will also get the memory. Show is also get the memory. Clear the point? Now all are loaded into the heap area. All the members, all the non-static members are loaded inside the heap area. Now everything is completed. After completion, this address is loaded into OB. Clear the point? Now what OB consists of? OB consists of the address where my instance members are created. I will repeat one more time. Whenever you are using new keyword, some memory is created. Inside the memory, all the instance variables are loaded. After completion of all the instance variables, so finally whatever the address that is created, that is copied into O. That is copied into O. Just this thing is happened. Just loading is happened, and after loading the address is stored in OB. Now what is the next one? OB dot show. OB dot show. That means you are calling the show method. You are calling the show method. Whenever you are calling the show method, automatically the show method, OB consists of address. So we are calling the show method at this address. What happened? Automatically a method frame is created. So there the show method is executed. This is the fifth step. So inside the show method, you are printing a value. So already A is loaded. Already A is loaded. So that is the reason you are getting the A value here. And also the object is generated from the class only. Now B. So within this address B is available. So printing B value. Now show method is completed. Destroy. Now, is any statement available? No. Closing bracket. The closing bracket in the sense the main is also completed. Now, destroy the main also. In this way, your Java program is executed. So this is the execution flow. This happened internally. This is not visible to us anyway. This is the simple example. So step by step, I will increase the level of difficulty by adding more than one method, update the variables inside the static method, and I will discuss the concept of remaining components, static blocks, and then constructor. You will get one by one. You will get the complete idea, not a problem. Now everyone clear? So only the point you need to remember is The static members will get the memory inside the class. The instance members will get the memory inside the object. Inside the class is called method area. Inside the object is called heap area. May every method, every program starts from the main only. Main only. The main is automatically copied into the Java stack area. So within the main, whatever the statement you are written, in that order, the statements are executed. Whenever you are using the class for the first time, all the class members are loaded. During object creation, all the instance members are loaded, and then the address is stored to the object. By using that object, we can access all the methods. We can access all the members. This is the concept how the variables and methods are executed inside the program. Remember, this is the very crucial role. Directly execute the program, you are getting the answer. What you learn? So there is no use. Internally, what happens? For example, if I change the variable in the static, if I change the variable in the static, what happened? Suppose, for example, inside this method, see this one, a is equal to a plus 1. Here I am changing the value of a. Here I am changing the value of a. Execute the program. Sorry, semicolon, just a small error. That is not a problem. Now observe. Now observe. Here what happened? Here I changed the value of a in the display method. But observe in the show method also we are getting the changed value. In the show method also you are getting the changed value. How? If you know the internal execution, then only you will get how we are getting the updated value. How you are getting the updated value. Okay. So anyway, we will discuss the remaining things in the step by step. That is the end of today's session.